Good morning, 12th students. Lesson number 3, Electrochemistry, part 10. Our today's topic is 3.5.1 products of electrolysis. Yesterday I taught you this example up to example 3.10 in part 9. Today's part is part 10, products of electrolysis. See, now products of electrolysis depends on the nature of material being electrolyzed, okay, and on the type of electrodes being used. It does not participate in the chemical reaction and acts only as source or sink of electrons. If electrode is reactive, you are knowing the three types of electrodes in 11th in oxidation and reduction chapter. You are knowing the types of the electrodes. Now if the electrode is reactive, it participates in the electrode reaction. So the products of electrolysis may be different for reactive and inert electrodes. Okay. See, if the electrode is inert, example, you are knowing inert electrodes, platinum. So it does not participate in the chemical reaction and acts only as source or sink of electrons. But if electrode is reactive, okay, it participates in the electrode reaction. So the products of electrolysis may be different for reactive and inert electrodes, okay, because it participated and it doesn't participate. So products are depending on the nature of these two types of electrodes. Now the products of electrolysis depends on different oxidizing and reducing species present in electrolytic cells and into their standard electrode potential. Now some are slow kinetically, that at lower voltage these do not seem to take place, and at extra potential called overpotential, extra means overpotential, has to be applied, which makes such process more difficult to occur. Now I am explaining you with the example. If we use molten NaCl, okay, the products of electrolysis are sodium and chlorine. Sodium will be metal and Cl2 will be gas. Now one cation Na plus 1, which is reduced at cathode, okay. So Na plus 1 gains electron and gives sodium metal. One anion Cl minus 1, which is oxidized at anode, and Cl minus 1 converts into half Cl plus electron, okay. So in this way you are getting sodium metal and Cl2 gas. Now electrolysis of aqueous NaCl solution. Aqueous I am talking about. Ahead I taught you molten NaCl, and this one is aqueous NaCl solution. The products are NaOH, Cl2 and H2. Na plus and Cl ions are. We have also H ions, OH ions along with the solvent molecules H2O. Now you see, I explained here up to now. We are saying the reaction at the cathode, there is a competition between the following reaction: Na plus 1 like molten electron Na sodium, and that voltage this H plus ion, because it is molten, so H ions plus electron H2 gas will also liberate. So you are knowing, no, they are half standard cell, so their voltage is 0. The reaction with a higher value of E0 is preferred, and therefore the reaction at the cathode during electrolysis is H ion H2O gas. This now if H ion is produced by the dissociation of, this equation is 3.33, this equation. Now but H ion is produced by the dissociation of H2O, so H2O liquid, because we are using aqueous NaCl. H2O plus electron use half H2 produced gas H plus OH ion. This reaction is 3.35. See, H2O, H2O uses plus electron and gives hydrogen and OH ion. But we are balancing H2O, so half H2. Okay. This equation is 3.35. Now, this I talked about the cathode. Now, at the anode, the following oxidation reactions are possible. Therefore, but H ion is produced by the dissociation. I explained up to 3.34, then 3.35. Now, at the anode, the following oxidation reaction is possible. Here at cathode and here sodium, H ion, aqueous. So, this again Cl minus 1 produce Cl2 plus electron. This one, this voltage 3.36. Then H2O also like this only, H2O. But 2H2O, 4 H ions plus 4 electrons are produced, so 3.37. Here voltage was 0. But here this. So the reaction at anode with lower value of E0 is preferred, and therefore water should get oxidized in preference to Cl ions. However, the net reaction may be summarized as NaCl aqueous gives Na aqueous plus Cl ion. This is the net reaction. Okay. But how? You have to show aqueous. So cathode H2O. At cathode H2O, half H2O, this one plus OH ion, and at anode Cl, this one gives half Cl2 plus electron. So net reaction is NaCl, okay, plus H2O. This you have to combine to this side. This side you are getting Na. Cl and Cl are going to cut, so Cl2. So NaCl molten means aqueous means H2O gives Na ion and Cl2 gas and gives OH ion and half H2O. I explained you earlier at cathode at anode both for the positive ion and for the negative ion and combined with H2O ion, but net reaction is like that NaCl plus H2O because aqueous they are getting NaCl, NaCl means half Cl2, H2O, OH ion and half H2. Combinedly they are showing this reaction. Now the standard electrode potential are replaced by electrode potential given by Nernst equation. Already I taught you Nernst equation to take into account the concentration effects during the electrolysis of sulfuric acid. The following processes are possible. So H2O at anode, if we are doing with sulfuric acid, H ion, okay, acid, so H ion, and E cell is, this equation is 3.38. Now at last sulfuric acid, so SO4 minus 2 gives H2O at minus 1 plus 2 electron, this potential. For dilute sulfuric acid reaction 3.38 is preferred, but for concentrated H2SO4 reaction 3.39. Okay. So if the solution is concentrated, if you are using concentrated sulfuric acid, this you have to use, it gives sulfate ions, and if the dilute solution is there, then they will produce only H ion. Okay, small acidity. So this is for dilute sulfuric acid and this is for the concentrated sulfuric acid. Okay, now only I taught you today is very less, only 3.51 products of electrolysis only. So after this topic you have to do these index questions, homework 3.10, 3.11 and 3.12 based on this example already I taught you. Okay, so from tomorrow in the next lecture we are going to start our new topic, that is 3.6 batteries. So there are types of batteries. See, you can see the primary batteries, secondary batteries, okay, and fuel cells, 3.7 fuel cells and 3.8 corrosion. So 3 more topics are remaining, that is primary, secondary batteries, fuel cells and corrosion. In the next lecture I will teach you that. Okay students.